long line of people clamoring to get in at this point of the day. So in the interest of getting out of here on time, get you to the next sessions, I'll just get started right on time. And that way we'll have a little bit more time for questions and getting away from just me talking about a PowerPoint at you, which is probably not the reason that you're here. So just in terms of introductions, my name is Matt Pollock. Hi, I'm an embedded system engineer at National Instruments. I work here in Austin. And the topic for this session, hopefully you're in the right room, managing open source projects in LabVIEW. Any of you working right now on anything that is currently open source? Are you using someone else's open source project, or are you managing your own?
We want to manage one.
Okay.
We're figuring out how to do it.
Anybody actually contributed to an open source project previously, whether LabVIEW or not? So, good. Good. Anybody contributed to a LabVIEW open source project? Which one?
Well, it's ours, our open source project. We open source some stuff through the lab.
Nice.
So
Which stuff, if I may ask?
it's the seismic microgrid controller.
Cool.
We've only had one person look at it. So. Two. Oh, it's good.
You might double your downloads. All right. So usually I don't have to talk too much on this slide. For whoever comes to this session, usually this is already a moot point. So for the people in this room, the answer is, why not? So there's quite a lot of technology stacks that are out there that do things that are incredibly valuable for us these days. Almost anything on the web is based on a foundation of open source software. How many of you have an Android phone in your pocket? Open source software. If you're using .NET Core in any of your APIs and the work that you do, that's now open source. Even Microsoft, the champion of monoliths, is opening up their source. It's very much what the future is going towards. It doesn't mean that anything that you make you need to publish the source code for. It does mean that we shouldn't be all reinventing the same wheels over and over again and getting version 1.0 bugs on everything that we ship. We should be using tested, stable foundations so we can focus on the interesting parts. That being said, there's still some of the less interesting bits to talk about, specifically the licensing part. I want to get this out of the way at the beginning so we can focus on things that are a little bit more interesting. I am not a lawyer. If you make any decisions based on the advice on this slide, you're a fool. Please consult somebody who knows what they're talking about. This is a brief overview of what I found when looking at the licenses so that I could figure out which licenses I need for my own projects. The answer is different for everybody. And what I found when speaking with customers and other users about open source software is open source has a bad name in some organizations because of the ones on the left side. Anybody know about copyleft licensing, viral licensing? You touch this code, now yours is open source too? Yeah. Not all the licenses are like that. Those would be the GPL style licenses. Those are, they tend to get political almost in terms of their usage. It's almost like a religious debate of what's the correct open source license. Yep.
Well, except for the one on the far right has been a showstopper in more cases than the others for years.
That's why I put them on the very edges, and I don't recommend either of the edges. I go with the middle. So you've got anything from the GPL licenses, which is anything that touches this code must be published publicly, and you must release everything, no exceptions. Again, not a lawyer. Far right side. Here it is. Go nuts. Not our problem. We don't care. Public domain. I wash my hands of it. And that's also worthless from a perspective. If somebody wants to get support for something, if somebody wants to actually trace back who wrote this thing, that license doesn't help you out much. Middle two are where we see most of the effort these days, including from NI's side. So either Apache 2 if you don't want to get sued for patent infringement, or MIT if you want to be more permissive and just have a very simple license. Again, I'm not going to go into the deep complexities of this. There's some very nice websites that do so. And again, don't make any decisions based on this. If so, you're a fool. Do your own research, please. Any of you use these? Which one? I heard GitHub. Anybody using something else? Bitbucket? Bitbucket, okay. Did I miss one that somebody's actually using? Okay, good. No obscure ones. Yay. So what I found is if you're looking at a place to put your open source project, or to find an open source project. If you look at these three, you're covering 99% of the universe that's out there of current non-craftware product. SourceForge, good luck. But typically what we're going to look at is the source control hosts. The hosting providers are one of the best resources that's come about for open source software in the history of the movement. Because setting up the server, getting the storage space, getting the web hosting, making it easy for people to find the code, contribute, make pull requests, submit issues, they handle it all for you for zero cost. I can afford a budget of $0 for public projects. If you want private repositories, if you want code that's not visible publicly, usually they will charge you for that. But typically for open projects, they will not. So no ITAR-related information goes on GitHub. However, if you're going to be building out a reusable component for running unit tests in LabVIEW, why not post it up here? I'll tell you why not later, because we already did that. You should use ours and not build it yourself. But yeah, everybody here using source control? I saw a few people that are either tired from the conference party or didn't say yes. So I offer you this, a simple decision matrix of do you need source control? And the two questions you must ask are, do you ever make a mistake? Or if you are perfect, are all of your colleagues perfect? If you still think so, no. I will claim that therefore you are not testing enough. You need source control. If you've ever made a mistake and want to roll back your work to the point where it was working, and you don't want to have to go through a nightmare of cross-linking, you need this. And just as a public service announcement, no. I think most of us have been guilty of that atrocity more than once, of source control being the shared network drive where we put a zip file. And then we get names like this foolishness of project copy final version 2 fixed bug. Really this time, I swear. Don't use this one. Anybody ever done that? Yeah, I'll admit it, I did it too. It's embarrassing, but everybody starts somewhere. So in case there's any confusion, that. No, stop it. And usually what I hear from customers who are first deciding if they actually want source control or not is how much of a pain is this going to be for me to use? How much is it going to slow down my work? I don't want to bother with that. It's gotten to the point these days where it's very, very simple and straightforward and doesn't have to get in your way whatsoever. And if we're talking about clear case, all right, maybe not, but Git, newer versions of Perforce, the newer versions of these source control mechanisms are very nicely streamlined and get out of your way. I'm a big fan of tools that don't slow me down, and these have only sped me up. You might feel it's slowing you down a little bit until you make your first mistake and want to roll back, at which point you will be singing its praises. Especially if you do commits more than once a week, you should be doing them more like once an hour. Because then all you have to fix is what you did last hour. I can usually remember that. I don't really remember what I did last week, especially if NIWeek was in the middle of it. No way. All right. In terms of open source from National Instruments, one of the things that we're doing is trying to move more towards publishing our software open when we can. And that's taking a couple of prongs, one of which is contributing to open source projects that we rely on, rather than just being a leech and downloading it, using it, but not actually helping fix anything. We're an active contributor, especially to the Linux kernel, the PreemptRT patch set. We offered a implementation of the salt stack for Windows. There's a couple of other nice pieces that we've submitted. And all that's going to be under the NI GitHub page. Also the National Instrument Systems Engineering Organization. Any of our reuse designs, any of our reference libraries that you can download on the Tools Network, we've gone through the process of open sourcing all of those as well. Those are going to be posted here again on GitHub. We're defaulting to GitHub. GitLab, Bitbucket, they both work fine. Usually I find Bitbucket, if your organization is paying Atlassian lots of money, Bitbucket makes a lot of sense. If you don't want to spend a lot of money, usually GitHub makes more sense. Trade-off. They're both nice. And GitLab is the spunky up-and-comer that's trying to disrupt the other two, and can also work just fine. And if anybody uses Veristand, you need to know about the Veristand add-on in this repository, because that's where we're hosting all of the custom devices for Veristand that we develop. The code quality there varies, but we're trying to post everything publicly such that at least it's out there. We document its quality, and we can improve it, rather than just languishing on a Perforce server internal to NI. I agree. The first step is admitting you have a problem and making it open so that people can see the problems. Otherwise, they'll never get fixed. But besides these, the one I want to talk more about, rather than giving a generic, boring presentation consisting only of PowerPoint smart art diagrams, is this one, the Distributed Control and Automation Framework. Have you heard of this thing? A few of you have. Yay! You've probably been to some of my presentations. So this is, to my knowledge, the largest open source LabVIEW project on the planet. We're over 50 repositories, thousands of VIs, all hosted on GitHub under an Apache 2 license. Meaning you can download this, put your logo on it, and sell it, and we don't care. And we specifically wanted to do it that way because we found that customers were having a really hard time taking a NI embedded piece of hardware like a compact Rio, single board Rio, etc., and making a robust, usable system in the field. Starting with a blank VI and asking someone to get the entire software stack there, reliable, without memory leaks, running as performant as possible. It was unreasonable to ask customers to do that every time and expect success. So what we did is incorporated all of the knowledge in system engineering and built a reusable modular application framework. If you wanted to build, for example, a protocol gateway where you're pulling data from 3 different Modbus PLCs, something from Ethernet IP, something over OPC UA, and push it out to the cloud with DDS, we can do that in about an hour, start to finish. Because everything's already built, it's just a matter of configuring the pieces. Building blocks, you connect to them. This session is not about DCAF. The session is about how we manage DCAF under the hood. If you want to know more about DCAF itself, come to our session at 12:45. We'll be talking much more in depth about what this thing is, how to use it, what it's for, how you can contribute. Just to give you an idea of what we're dealing with here, this is a highly modular design. We try very hard to avoid the giant code monolith, not just the single VI that stretches on forever, but the single project that tries to contain 15 different sub-projects within it. We separated each of those individual pieces out as components, each built as a VI package, and multiple layers of VI package dependencies so that we can understand what we need. Install the top-level DCAF core from the tools network. It automatically pulls in everything underneath it. It means we don't have to rebuild every single component of this thing just to get a fix on the DCAF progress bar. That would be silly. Instead, we can just make a change to this very simple library, rebuild that one, push it out, don't have to change anything else. Much less risk, much less chance of us doing a stupid mistake that brings down an entire framework. Have any of you ever had a bug? Good. You're supposed to laugh at that, because if you say no, then you're lying. How long did it take to catch your bug? You ever tried to debug an embedded system in the field? You ever tried to debug a system that's on top of a windmill in Kansas? How about one in the middle of the Baltic Sea? You probably don't want to start your debugging effort with, I should do error handling. You probably want to build things in early and catch bugs as soon as you can. Have you ever had a user of your software complain about one of your bugs? Have you ever had a user of your software complain about a bug that you fixed before you gave it to them? We like that case a lot better. We're going to have bugs, we're going to have issues. We try and find and eliminate them as quickly as possible before anybody else has to notice or be affected. What's that?
I was just thinking that we play the same world because we do time-critical projects. We must deliver fast to the client. We do not have time to test everything up to start to the end. Every numbers, every condition we have. So maybe you can do it on your desktop at night, but in real-life project, just have to wait for the customer to say, hey.
So I don't want to give the impression that there's a magical fantasy land where one-button testing can solve all problems. Such a land does not exist. I wish it did. However, what I've seen in interactions with customers over the years is that there's a phrase, don't let the perfect be the enemy of the good. I see customers saying, I can't test anything because it's hard. Even if what you're testing is just, does it have a clean run arrow today? That's better than not testing anything at all. And you can build up the infrastructure piecemeal as you go. It's not hard to get those individual pieces in place, and even something simple can help you. Some organizations, especially if they've got longer project life cycles, can put more of their effort into getting robust test suites. Even if you don't have the time or luxury for that, at least make sure it builds. And we've got some tooling that can help you automate that process, such that you don't have to spend all of your day clicking the button and waiting for the progress to finish, and just sitting there twiddling your thumbs for an hour while it does so. We've got better things to do, I assume. All right. So, quick list of tips. Biggest one is break up your system. Don't have one gigantic project with 3,000 VIs in it and expect that you're going to have bug-free software. It's unlikely to happen. Maybe you're perfect, and if so, we'd love to know if you're available for employment. But I've never seen it myself. Biggest ones is build your components separate from each other. Separate projects, separate source code repositories, separate builds, where any consumer of that project uses the export. Yeah?
So Matt, when you're talking about separate repositories, if you look back on the previous slide, would like each of those boxes be a repository?
Yep.
Typically?
That is exactly how we structure it, and I'll show you exactly what that looks like. So this is what's worked for us on a fairly large and hairy project that's being used by dozens of customers worldwide. So it's not pie in the sky, it's not an idealized diagram, this is what we actually ship. And I'm not going to say this is perfect, it's far from it, but it's what we've managed to settle on and feel like we don't hate this project while working on it, which is an improvement over some things I've worked on before. And
So I've always avoided breaking things down this much into packages, because every time you release anything, it has to be rebuilt.
yep,
And that's a pain in the rear.
It
Is
is.
the presentation gonna change my mind on that? Or do you agree that it's a pain in the rear?
it is a royal pain in the rear, which is why I want to automate it as much as I can. I'd rather my server hate life than I do.
Does it like impact your schedule? Is it like still like, it's gonna take a while for the changes to propagate, and you still find yourself waiting many hours?
So part of the things that we do is, almost this last bullet, limit the dependencies as much as you can. Typically, most of our bug fixes, most of our work is something that's entirely encapsulated within a single package. Meaning I don't have to rebuild everything else to get an update to the progress bar. I update the progress bar, and that's it. Everybody else just pulls in the latest on that one, and is good. And in terms of rebuilding the top-level executable that uses all those packages, yeah, it still takes a while to build it, but I can do that build automatically when I change something else. So it might take a while, but it's happening while I sleep. I don't care. And along with that, the last one there, last two, don't break the API. Add a function, don't delete a function. That's why in a lot of the Microsoft APIs, you'll see functions like iNet Browser 2, iNet Browser 3. That way they don't break the crappy interface that they put out with iNet Browser 1. They just provide a better one for people to migrate to. And similar here, you don't want to mess with your connector panes on any public device, because that breaks things, that causes people to shake their fists at you and say, what the heck are you doing? And the last one, test. I feel like a dentist saying floss. Because anytime we tell people to test, everybody says, yeah. I know I should test more, but I've never been able to make a dentist happy with how much I floss. I've never been able to make a project manager happy with how much I test. But you at least have to say, yes, I'm doing it. You at least have to make the effort to improve where you are. Otherwise, you're going to lose your teeth. Similarly, you're probably going to lose your job at some point if what you ship never works. Okay. Anybody doing this? A few. I've got another session right after this specifically on our build system that we use for continuous integration for DCAF. I'm going to give you the brief couple slide overview here because it's important, but we're going to go much more in depth with this in the next session. So the idea being, for DCAF, we actually build every single commit to source control. run unit tests on every single piece of code we submit. That way we know exactly which commit broke something. Even something as simple as, oops, you broke the run error. We'll know immediately, within about 15 minutes of submitting the change, that we did something bad. It's pretty easy to fix what you did in the last 15 minutes, an hour. Again, probably not so easy to look at everything you changed in the last week and figure out which one broke a type def. Oops. And the whole point of this is that you have something stable that you can get out when you need to. It's not a case of work, manager says it's time to get this thing in production. Oh crap, I should start testing now. Ideally, you've been testing the whole time. At least as much as you can. Even if you can't do full stack testing, again, at minimum, make sure the exe builds. It's a really simple sanity check. It doesn't take a long time to set up. And it has saved my bacon several times on DCAF already, where I submitted a change that broke things and I didn't realize it until the test results came back and said, hey, stupid, you broke it. At which point I can go fix it before anybody else knows. This is what our pipeline looks like for DCAF in terms of what we do with our server. When we push a commit into any of the repositories in the entire GitHub organization for DCAF, we're going to check out the source code for that repository. We're going to run all unit tests defined in the LabVIEW project, get results in JUnit format, report those up to Jenkins. If it passes the unit test, we build our VM packages. If the package builds successfully, we push that to a internal VI package manager repository that we use for testing. And then currently it's nightly, but we're hoping to increase this once we get some more build machines spun up. But then we do a nightly integration test where we take every package in DCAF, build a gigantic executable that uses all of them for Windows, Linux ARM, Linux x86, and see if we broke something with the entire set together. And ideally, we'll get some more automated performance and benchmarking tests associated with that. But in the spirit of agile development, we shipped what worked first, and we're working on more to add to it as we go. Yeah?
So what's the difference between the unit test and the integration test?
Unit test does A plus B equals C. Integration test does the system make my engine fall over.
So is that still automated somehow, or do you have to have somebody look at it?
Depends on what kind of testing you have and what level of complexity your tests can do. In terms of what can be kicked off by Jenkins and a continuous integration chain, if there's a command line you can run to get those tests going, if there's a VI you can call to run the tests and get a report, if there's a test stand sequence you can run and have a known report location that you can pull in, you can integrate it into here.
So in your case, is it just more extensive? Is that why, I mean, why don't you just do the same thing at both points?
Because it takes longer to do an integration test. And the integration test covers multiple repositories. Unit test is a single repository that I break the run error on my progress bar. Integration test is does the progress bar get called, for example. And I'll say this right up front, if anybody's got a way to automate UI testing of LabVIEW applications, I want to talk to you, because it sucks. I don't have a good answer for it. I get that question every time I do the session, and you're right, it's hard. I don't have a good one for you there. But I can do a lot of the other grunt work underneath and make that go away. So, only got a couple more slides left before we actually do a demo of everything, and that's where I want to spend more of the time. This is our tool flow to actually get everything working. We use GitHub for source control. You could replace that with GitLab, with Bitbucket, with Perforce, with SVN, with something internal to your walls that's not public, that's fine. Jenkins knows how to talk to all of them with the appropriate plugins. Jenkins is a open source build orchestration software that is by far the most widely used continuous integration tool that's out there. By far, I think on an order of like 20x over anybody else. That means it's got thousands of plugins built by the community for just about anything. GitHub makes a change. Jenkins is directly pointed to the GitHub repository. It knows when there's a change. It will pull down the latest source. And in the source code, Jenkins can look at a special file called a Jenkins file. Anybody know makefiles? No? Rough equivalent where you tell Jenkins what you want it to do a build. Which like make would do whatever the steps are to build the software. Jenkins file is just a text file in GroovyScript. Groovy is a superset of Java. If you know Java, you know Groovy. If you don't know Java, Stack Overflow knows Java. This defines a set of steps that Jenkins can perform. And in our case, we actually do a two-layer approach where there's a shared pipeline script. I don't want to write the same file 50 times. I write a file that just calls a common file. All 50 of my DCAF repositories have a unique Jenkins file because they have to. Each of those Jenkins files just calls into the same pipeline script. I'm lazy, I want to change one. Again, next session goes into detail here. The cool part is we can also have Jenkins invoke LabVIEW. If you've ever tried to get LabVIEW to talk to the command line and provide console out, good luck. LabVIEW was built 30 years ago as a user-based application. It's an editor. It's not a command line tool. It doesn't know how to provide exit codes to the command line. So James McNally over there, hi James, built out a very simple tool that's just a C# proxy. You invoke this over the command line. It calls LabVIEW. And then there's a couple of VIs you can sprinkle into your LabVIEW code to get data back to the console, which then gets put into the Jenkins labs. Yep.
Is that fixed in next gen?
Is that fixed in next gen? It is something that we are deeply interested in fixing. Is it fixed in the 1.0 release? No, because we don't have a way to automate the app builder because app builder isn't there in 1.0. So we will have an answer. The answer is not there.
Yeah, I guess we are looking into providing specific tools for building and building as well as creating packages. We are considering having separate tools from the LabVIEW, rather than invoking a LabVIEW.exe. We're possibly looking at having other tools that sits side by side with LabVIEW.exe so you can go build and get all the right standard in, standard error, standard out back.
We want this problem solved because we've been living with it for a long time. We're tired.
So I'm not trying to pick on your typing, but in
Please.
that second from the right,
Yep.
where it says invokes VI, it's really more invoking LabVIEW per se, right?
Not quite. What it does is it calls LabVIEW and invokes a VI in LabVIEW. Again, if you want details,
So
next
that
section
VI
we'll
is
go
what's
in
going
depth
to do the
there.
other things, is that what you're saying?
Taken?
The VI that gets invoked in step batch file there, that's what's going to do all of the other things over on the
Correct. Example, you use the command line interface tool that James made to invoke the thing that builds builds VI packages. That's just a VI that wraps the JKI via PM API. His tool is what lets us report the results of that back and provide status updates while it's running. Again, if you want details, next session. I didn't have time to do both in one session and do justice. So one of the things that I get asked a lot is what kind of workflow with LabVIEW actually works with, for example, Git or multi-developer projects. I will not get up on a soapbox and say this is the way to do it because it's different for every organization, every group of people. I will say this is the way that works for us and how we've settled on a process that has the correct amount of friction in it, but not enough to piss off our developers so much that they stop working on it. And just to give you an indication, I think we're up to, is it 19, 20 contributors now that are working on DCAF. That includes folks at NI Corporate, in our branch offices. It also includes customers on multiple continents that are submitting through the exact same process here. So this is actually used in production. We actually do this. I'm not just preaching something that sounds great but nobody will actually use. I find it actually is very valuable for us. Walk you through this in terms of some pretty slides. Then I'll shut off PowerPoint and actually show you how it works in real life. We're going to run through the entire process of reporting an issue, getting a change in, branching, pull request, merging, review, acceptance, build in the last 15 minutes of the presentation. Because that's how long it takes. Yep.
I have a question. This was on the previous slide. How much time does it take to go through the flow to have your first running test?
To start the unit tests, it's usually between 5 and 10 seconds from invoking.
Going through the flow, I mean, you set up your GitHub reverse batch file and invoke issue 0 and run the unit test on time.
You set up a new system from scratch?
Yeah.
I trained a applications engineer who has never touched Jenkins before, and within a week she was up and running the first time. When we then changed over the build system entirely and had to do it a second time, she was up and running in under a day.
One day to set up, by these settings.
The learning curve of Jenkins is a major challenge, and that takes time. Once you're past that, repeating operations or tweaking things is actually quite straightforward. And in terms of the LabVIEW side of the tooling, assuming you already have a unit test to run, and you already made unit tests, getting that integrated into the system takes under an hour. That part is very simple. The harder part is deciding what unit tests to actually make and getting good test coverage. That is an art in and of itself, which I cannot do justice for in a 45-minute session. You could do doctoral theses on this. Good questions. More, please. Don't make me just talk about PowerPoints, please. All right. Andy?
I think the important thing to drive home is that you need to make a home for unit tests.
Yes.
So once you've made the home, then you can incrementally add. But the hardest step, that first one, is making a place to put it.
Yeah. And we've put in a decent amount of work to try and lower that barrier. And all of the tooling that I'm going to show when we get to the demonstration part is open source. It is on GitHub. You can download it right now and put it in place without having to go through the process of figuring out what those pieces need to be and how they need to link. We've already did it. We published them. You can just use them. You still have to set up your Jenkins to point to them, but it's much simpler than having to create them all from scratch. And we love suggestions. We'd love even more to get pull requests and submissions of how to make them better. The beauty of open source, if you see a problem, great, you fix it. Or at least report the issue to us so that we can understand that there's a problem. Yeah. All right. Basic developer workflow that we follow with DCAF. Shiny pictures. This is as close to marketing as I ever come. All right. First thing we do is everything that we work on for DCAF has to be based on an issue. For those of you not familiar with GitHub parlance, an issue is a feature request, a bug report, a wouldn't it be nice if, blah, blah, blah. A unit of work, a user story. Depending on your process, you can have different definitions for what this stuff is. Its key is that it's documented, it's public, and it's associated with the repository you're working on. You don't get to just go in there and play. Make an issue about what you're about to play on, and then go do it. Yeah?
Is there somebody that is making decisions as to which issues are accepted?
Yes.
Okay.
Our process that we follow is anybody can submit an issue. And by anybody, I include you. It's public, it's on GitHub. We don't use GitHub as a mirror of some internal repository. That is the repository. That is our bug tracker. That is also our project management tool that we use. GitHub has an interface that they just released 2 months ago, which is actually pretty nice, where it lets you manage all the open issues that are present in an entire organization. And you can basically choose, Kanban board style, which ones are going to go into your sprints for that one. And we basically go through and just look at all the issues that we've got, and we decide, yeah, we need to do that this time. Move them over to do, and then we pick them off as we go, and we have time as individual developers. We basically look at that list and pick whatever interests us, and with the understanding that we need to get through the whole list by the end. So they can also be assigned so that 3 people aren't trying to fix the same awesome bug, and nobody's trying to fix the boring yet important one. We do all of our work in branches, always. Nobody, including the people who have administrator access, even have the ability, we can't do it, to push straight to master. It cannot happen. You can set that up in Git. GitHub happens to have a very nice interface. Just click a couple of checkboxes, and then you can't screw this up. You can't accidentally push to the wrong branch and kill the production software. It won't let you. It will say you are not allowed to do that. Use a branch. The idea here is that you pick which issues you're going to work on in a particular repository. I want the progress bar to be blue, not green, for example. Make a branch off of the master for that one. Give it some name to let people know what you're working on. Our branch list then becomes basically our in-work list. do all your work in that branch, and make frequent commits. Frequent, I mean, I'm fine if you commit every hour. Cool, doesn't bother me. You submit on Friday evening when you're about to go home and that's it for the week, then no. You gotta do it a lot more often than that. Nice thing about Git is you can be making commits even if you don't have access to a source control server. If you're on an airplane, and not from a Middle East country because stupid politics, you can get on your laptop and make submissions to your local version of Git, and then when you land, you can push all your changes up to the server. You don't have to stop. There's not really an excuse not to be making commits to source control. And I say this having actually made commits on planes. Yeah, James.
So, the other way I've seen things work when I was trying to understand it is that normally I thought you couldn't write to GitHub repo unless you were added as something.
So when I say branches, if you're an external contributor, fork, just the same. That's fine. And my point is that nobody, even us, gets to go straight into master. Idea there is once you either think you've got your issues addressed, or you're ready for somebody to take a look at it and give you commentary or code review, even if you're not done, make a pull request. That is, on our side, going to automatically trigger our continuous integration server. As soon as you either make a branch, if you're an internal contributor, or as soon as you make a pull request, if you're external, our CI server will notice that within half an hour and spit out a build for you. Even if you're just James submitting to DCAF, we may not even know who you are, but you can still use our test infrastructure. It's open, it's public, use it. We already built it. Don't reinvent this, at least for our project. And if you want to do it for your own project, we posted up the source of everything we did also. You can steal that. And the idea here is that our CI server validates that we can get clean builds out of it, no errors, no failed unit tests, no failed integration tests. Yep.
I remember working with LCM.
Yep.
When doing branches, I had major issues with LabVIEW libraries. Do you have the same kind of thing here?
We tune our workflow specifically to avoid the obnoxious pains we've experienced over many years of fighting LabVIEW with source control. Part of that is to separate things out into many, many repositories. For example, a reusable API lives in a library, which exists in its own separate project, which gets its own separate Get package build. Nothing links against the source code of the library, therefore it's easy to manage which version of the library you're working with.
So if you're working on a library, a specific API on a library, you make a branch and modify the complete library, that's it? Or
We try very hard in our development process to have branches that don't live very long, and to ensure, because we have so many branches, so many repositories, we have more repositories than we have developers. That means that the odds of 2 developers making simultaneous changes to one branch are relatively low, and we also enforce in our policies that you should avoid that whenever possible. We also tune over here. I'll get to that in a second, but we can actually validate that there are no merge conflicts allowed in master. You have to resolve them in your branch first before you can push up. Also known as he who submits first wins. If you're the first one to get your pull request in and it passes all tests and gets rolled in, you had no merge conflicts because you're the only one making changes. If there was a second person making parallel edits, well, they have to integrate yours first before they can submit anything. It encourages us to keep those branches short-lived and for us not to try and do giant blobs of work that are hard to test. We found it's a good carrot and stick combination for developers. Again, this is what works for us. All right, I want to zoom through this a bit because I want to get out of PowerPoint and actually show you how this stuff works before we have to get out of here. So we set up on our server, and you can do this in Git or on GitHub. SVN, I think, has such options, but I cannot vouch for it. You can't, me as an administrator of the DCAF repositories, I can't accept a pull request unless these conditions are true. It won't let me. I can't just say, yeah, it should be no problem, click. I have to go through the process, and it's enforced by source control. All tests have to pass, no errors, no integration testing. some other human with right access has to have done a review, or at least said they did a review, and put their name on it and says that they approve. We're not perfect, we don't do it perfectly every time, but there's traceability, and if somebody didn't do their job to do a good review, we know who it was and we can talk to them. And yes, sometimes that's been me. And the key one is that there's no merge conflicts. You got to do it in your branch first. Branches get messy, master is never messy. Master can be shipped today, at any time. And that's the whole point of this. And then once we're done, we get rid of the branch, close everything out, mark it as done on the project side. Enough PowerPoint. Let's actually do it. One of the modules in DCAF is an LED module. Give it a blink code and it'll blink the LED the appropriate number of times. Amazing how often we've seen bugs with that. Seriously, I managed to actually make a showstopper bug on DCAF with the LED module. It's happened. If you update the LEDs on an anti-compact Rio device at 100 kilohertz, the system is unhappy. All right. So I'm going to just make an issue. Here's our, you can't see that. That's there. Okay. Here is the GitHub repository for DCAF. github.com/LabVIEW-DCAF. Here's the LED module. You want to see how many repositories we've got? There's quite a few in here. Again, one for each individual package that we build. Do I get networked? Yes, I should. Woohoo! Goody, GitHub's down for me. Benji.
Yeah.
You do the issue.
Yeah.
So let me see if I can just kill my network and bring it back. If not, we'll just cheat. Isn't public Wi-Fi great? All right, we'll give that a sec. Let's see if that did it. Yeah, that'll work. Resolving. You got network?
Yeah.
You do. Yay, redundancy. All right. When we're doing any type of issue reporting on our modules, we do it all in GitHub. Same interface you can use. Same interface any of our customers can use. Just go to GitHub, go to the module you want to report a bug to, and, oh, I don't know, let's just get rid of some of those old files that are in there. For example, version.txt does not need to be there. Just make that go away. That's old. Ideally, we give some kind of useful information up here. And while you're working on that, I'll see what I can do with this.
So basically, I created a new issue. The things I have to do here is I have to assign it to someone, so I can assign it to myself. Also, you can add labels to say if it's a bug, if it's an encasement, or what we're doing. In this case, just let's call it a bug. And basically, we can also design if it's in the project when we're managing it. So once the issue is created, then I can actually work on it. So for doing that, I will open my GitHub client. Now, on the GitHub client, one of the first things I have to do is get to the latest value. So I have an old state. So I will just now sync the system. And with that, I will have the latest version of the master in my machine. As we said, I cannot work on the master. So if I make changes in master, they will be lost. So I need to create a branch. So I just create here. And let's say I'm going to fix this. If I see my issue is number 6, so let's call this branch fix 6. And I create a new branch. Now that I have a new branch, I can start working on it, and it's in my local repository. So in this case, I will just open in Explorer, go to my file that I don't need, that is the version.txt. I can delete it, and that's everything I need to do right now. So I can come now to GitHub, go to changes, and commit my change. So one of the nice things with GitHub is in text, if you add fix number 6, by just doing this, it will automatically close the issue. So I don't have to remember if I close it or not. If this is going to fix it, it will be there.
And it keeps track on the issue as well. It's a two-way link, so that you can easily go back to where somebody said it was fixed, and maybe it wasn't. You can go back and see. Or if you want to see what they did to fix it, you can do that as well.
Now,
traceability.
Yeah. Once I finish making my issue, I can make a pull request. It's saying it's fix 6, and then I send pull request.
That works. I got backup. Okay. Each one of these. The fun of doing live demos on production. Fun, huh? All right. Switch back over to me. See if it's happy. There we go. Okay. So here's that page again. I'm just going to refresh this one. It works if I don't have HDMI plugged in. That's fun. All right. I'll refresh it this way. Surely that is not possible. Yeah, my network's just bad. Switch to the other one. There are many things I can get around, but losing Wi-Fi is a hard one. Let me see if my VM is still happy with my network. Sometimes that works. If not, then we will punt. All right. Invisible. Yeah. All right, my virtual machine has decided to eat my network connection, so we'll do it all down there. No problem. So what you can see up here, once Benji submitted that, I have an issue and I have a pull request. I actually have bookmarked links that give me a list of every open pull request in all of DCAF on any repository, also a list of any open bug. So it's pretty easy to manage that. Yep.
Can you just talk a little bit about how you configured it so that you were the one who received the pull request?
I didn't. I did not receive the pull request at all. It's just showing that it exists. It's not directly tied to me as a user in any way. However, Benji could ask me to make a review. So here's that issue that came in. And what you can see over here is that it's waiting for a few things to happen before I can actually accept that and roll it in. It needs a review. And here's the yellow one. It's saying that it wants Jenkins to do a build first and get through that process before it even lets me do anything with it. Why should I bother looking at something that doesn't even build? Let the developer fix that before I even bother looking, which is nice. Saves myself a lot of time. And then I won't be able to merge until all the other things are clean. So let's get a build. This is my Jenkins configuration. It's just running on my virtual machine here. Because VPN on this wireless network, back to my office network, forget it. So this is not the production Jenkins, but it is a copy of the same configuration. All right. So rather than waiting for my 15-minute check of my repositories, I'll just hit build now. Otherwise, I'll be waiting a while. And what this is doing is running through our entire build pipeline. First by going in, cleaning out my directories, checking out the latest version from source control, of the one that he actually submitted. Oop. I lie. I'm building master. What I should be doing is scanning here. My mistake. Abort. All right. So I'm just going to rescan my entire GitHub organization so I can see if we've gotten any changes. This is what runs every 15 minutes. And what it's doing down here is it's going in and looking at every single repository and every branch of a repository in source control in GitHub to see if a new branch was made with the Jenkins file in. He made a branch just now. He didn't make a Jenkins job. He didn't touch Jenkins. He doesn't know Jenkins exists. Jenkins will go in and find it so that we don't even have to touch this side of the problem, which I am a major fan of. I'm lazy. I don't like to have anybody do work that does not need to be done. It found fix 6. It's already building it. He didn't have to do anything other than submit to source control. That's it. Done. And the reason why we got that is there's a plugin for Jenkins for GitHub organizations, which will automatically scan your GitHub organization, all projects within it, and look for Jenkins files in any branch and see if there's new branches created. Any change in the source code in any branch, or any new branches or pull requests that are made, trigger either a new job to be created or a new build of that job to be made on the Jenkins side. I don't have to touch it. I like that. Yep.
So I'm not saying that what you're doing is not awesome, because it is, but just so I understand, if I received that pull request, or if I saw that pull request was there, I could still go in and do a normal build, or pull and build and all that stuff.
You certainly could.
Manually at that point, right?
And if you wanted to do it manually, you still have the ability to do so. It does not preclude your options, it just automates the work that should be done every time anyway. And the nice part about all this is that it also collects all the status, all the unit test results, and will also report back as each stage of the process goes. How did it do? How long did it take? Was there an error? What was the console out from James' CLI tool to tell me what went wrong? That's helped me immensely in debugging this. Example, I can get a file not found error, get reported back out, and my Jenkins log tells me which file LabVIEW couldn't find. Pretty easy for me to go back to a user and say, hey, fix this. And while that churns, yeah, this is one I canceled before when I shouldn't have been building master. Oops. Delete build.
I noticed you're using 2014. Is there
Yep.
something in there that manages so that all these components are done with the same version of LabVIEW?
Come to my session next.
Okay.
Yes, there is. Like I said, I didn't have time to go into the proper depth there and do this whole thing together. But what I wanted to show in here is if we go back to GitHub, it's already talking to GitHub. It's being built already. This is public. You can see this on your phone right now if you go look at it. You don't have to have access to my internal Jenkins server to see that things are happening. You also don't need access to my Jenkins server to see the build result. Pass, fail, unit test, failed, here's the console log, etc. You don't have to get access to Jenkins to do it. You don't even have to know Jenkins exists. And from a user perspective, from a contribution perspective, that's how you want it. You want them to care about what they need to get the code working, and then magic happens to get the results spat out. The magic was not hard, and all the tooling is open source. Rather than sitting here waiting for the extra minute it's going to take for this to finish, I'd like to show you where you get those tools, and then hopefully I can come back here and show nice green things. Since we're running a little bit short on time, I want to get you to your next session. I also have to get to my next room so I can set up for the next session. Hopefully the Wi-Fi works better in there. All right. Get out of the VM. If you want a package that contains all of the individual steps that I'm invoking from Jenkins in terms of wrappers around the Project Builder API with LabVIEW, wrappers around the VIPM API, wrappers around the VI Tester API, those are available in a package you can download now from Tools Network. This has the LabVIEW VIs that interface with James' CLI tool to get that data back to the command line. It has the Groovy scripts that I'm actually calling in DCAF in production to make those get integrated into Jenkins. And that can give you most of what you need to get this set up on your own. You still need to configure Jenkins. You still need to figure out what your unit tests are going to be. But the calling infrastructure, you shouldn't have to care. Now, we also have included in here a converter for unit test framework results into JUnit, which is something that I really wish we would roll into the product, but that's just feedback for NXG at this point. And in the meantime, it's a free package you can download off of Tools Network. This is what you need to get all the individual pieces. You'll still need to go to James's GitHub page to get the installer for the little C# proxy. There's a link for it in the package, plus give him some traffic. All right.
And at some point soon, you should not need that process.
Yes. Yeah. All right. So while this is still doing its thing, any other questions in the last couple of minutes before I have to get out of here?
Your question.
Yep.
To whoever wrote the CLI, does that work on Mac?
No.
Does that work on Linux?
No. So right now it's written in C#. I guess supposedly now you can push .NET to Linux. I Honestly, I'm not actually a C# developer. I just picked that as something I thought I could quickly put together a console application in so that we can get this going. Yeah, let's find out. I'm happy to explore it.
Probably breaking.
So the other thing is basically all it's doing is talking TCP to LabVIEW. So it starts at LabVIEW and it has some arguments which says connect to me on this port, and that's a very basic messaging system. So there's actually no reason if we needed to use a different proxy bit for Mac or Linux, we could rewrite that code and use the same library in LabVIEW. So that could be an option.
I think it's very cool. Thank you.
And in terms of the build, it actually did get through everything. Presuming that my laptop actually had workable Wi-Fi access, at this point it reports back to GitHub and turns my boxes green. Rather than pretend that it actually did so, I'll just tell you my network went down again, so it didn't get that hook back to GitHub. As soon as I get to a usable Wi-Fi network, that should come through, however. Yeah?
Can you talk a little bit more about the backwards compatibility requirement and the bloating of the APIs and how you manage a decision that, okay, this has gone too far?
Which APIs?
Of API, for example. That would be the control panel in that particular case, or the menus for API.
At some point, you may have to make a breaking change. That happens.
How do you manage them?
Ideally, we stop development on that package and make a new one.
Okay.
And anything that we are aware that uses it, we switch over.
Understood. Thank you.
That way we maintain what was there, we just stop improving it. It's better than just breaking something else. Yes.
So there's a concept used in some other languages for packages as well, the semantic version. So what that basically says is if you only increment the major version number and a breaking change. So if you're sat working on something and you see it goes from 1.1 to 1.2, you can go, this won't break anything. If it goes from 1.2 to 2.0, you now know actually they've made some new breaks. I don't know how many people are doing that in LabVIEW. There's one solution.
Yeah. But we're right at the end of the time, and I do need to get to the other session to get set up. They're probably wondering where I am. If you want to see some more about this and get a little bit more in depth, follow me. Otherwise, we'll be around. You can find me. We're happy to chat. Just not right now because I got to get over there.